Pop psychology often frames dopamine as a happiness chemical, the molecule responsible for pleasure during a meal, a notification, or a major win. This understanding drives many high performers to chase constant chemical spikes, inadvertently triggering structural addiction and neurological burnout. Dopamine functions as the neurochemical engine of anticipation and movement. It is a mechanism of pursuit, powered by an underlying biological tension. This circuitry evolved to ensure survival by compelling us toward essential resources. It is designed to keep us in a state of relentless seeking, rather than static contentment. Maintaining long-term drive requires us to look past the initial reward and understand the brain's pleasure-pain mirror. Optimization depends on a precise balance, matching our external seeking behaviors with the internal mechanisms of satiation. Sustainable motivation is found not in the pursuit of constant reward, but in mastering the brain's internal architecture of craving. The hardware of motivation centers on the mesolimbic pathway, beginning in the ventral tegmental area, or VTA, deep within the midbrain. The VTA produces dopamine, firing it into the nucleus accumbens to initiate physical action and goal-directed pursuit. This circuit is modulated by the prefrontal cortex. Acting as an executive brake, it regulates dopamine release based on planning and environmental context. This chart shows the baseline firing rate of the VTA. At rest, this circuit gently pulses at a rate of roughly 3 to 4 times per second. Anticipating a reward accelerates this firing rate to 30 or 40 times per second, creating the physical urge to move toward a target. This chart shows how specific behaviors impact that baseline. Consuming highly anticipated food causes a 50% increase in dopamine release. Reproductive behaviors trigger a 100% increase, effectively doubling the baseline. Cocaine and amphetamines bypass the executive brake, causing a massive surge of 1,000%. From a morning cup of coffee to the pursuit of a long-term professional goal, we rely on these localized chemical fluctuations to force the body into action. If dopamine surges when we reach these goals, how can we be certain it isn't simply the chemical experience of enjoying them? To find the answer, researchers utilized a neurotoxin study on rats designed to isolate the experience of pleasure from the motivation to act. In the control group, normal rats will repeatedly press a lever, exert effort, and eat the food pellet they receive. Researchers then injected a neurotoxin to destroy the rats' dopamine neurons, leaving them unable to release the chemical. When placed directly in their mouths, dopamine-depleted rats still ate, showing clear signs of enjoying the meal. However, when food was moved one body length away, they remained motionless, unwilling to move even inches to get it. The experiment proves that dopamine is not required to feel good. It is the raw biological engine necessary to overcome inertia and pursue a target. Every time dopamine is released, the brain initiates a mirror image response to restore equilibrium. This chart shows the opponent process. Every sharp peak in pleasure is followed by an immediate downward deflection into psychological pain and craving that matches the initial surge. While this doesn't feel like physical trauma, it manifests as an intense yearning, the craving for one more bite of chocolate or one more scroll. This chart shows how the brain adapts to repeated exposure. With every subsequent surge, the pleasure peak becomes shorter and less intense. As those pleasure peaks shrink, the mirror image pain troughs deepen and widen. This shift changes the nature of pursuit. The goal is no longer to experience a high, but to escape the psychological drag of the trough. This neurochemical shift reframes human behavior. High dopamine habits become frantic attempts to alleviate the deep psychological pain of the craving. Pursuing massive dopamine spikes leads to a physiological crash, leaving driven individuals struggling to survive their own neurochemistry. The brain balances this dopaminergic drive with a separate pathway dedicated to satiation and the present moment. This system is centered in the raphe nucleus, which releases serotonin and endocannabinoids. The dopamine circuit governs exteroception, a focus on things outside our personal space that we do not yet have. The serotonergic circuit governs interoception, the feeling of contentment and presence with what is already in our immediate environment. Mindfulness practitioners use these biological systems to intentionally shift the brain's focus from external pursuit to internal contentment. A healthy emotional landscape is built by mastering the push-pull balance between the craving for what is next and the satiation of what is now. Because the prefrontal cortex modulates the dopamine brake, our subjective beliefs can physically change our neurochemical output. This was demonstrated in a study of college students testing how expectation alters the effects of stimulants. Every student was given 200 milligrams of caffeine. However, half were told they were receiving Adderall, a significantly more potent cognitive stimulant. This chart shows the results. Students who believed they had taken Adderall reported much stronger effects in focus compared to the group that expected caffeine. This graph shows that the Adderall expectation group also performed significantly better on complex working memory tests. Higher-level cognitive processes in the prefrontal cortex modulated the physiological release of adrenaline and dopamine to align with these expectations. Motivation is highly subjective. How you internally frame your pursuit directly dictates the volume of the neurochemical fuel your brain provides. How can we schedule our dopamine release to maximize motivation without triggering a massive pain crash? The casino industry perfected the answer to sustainable drive decades ago. Gambling is addictive because it utilizes an intermittent reinforcement schedule. This chart shows a predictable reward schedule. If a reward is provided for every milestone, dopamine peaks flatten out and motivation dies. Conversely, randomly withholding rewards spikes the anticipation for the next attempt, maintaining a high baseline of drive. To sustain long-term ambition, you must actively blunt your own reward response. When you reach a major financial or academic milestone, occasionally refusing to celebrate keeps the dopamine system in check. Mastery of drive is about protecting the baseline, embracing intermittent rewards, and recognizing that the pain of craving is the engine of pursuit.